My name is Jeremy Tapang and I will be showcasing a machine learning project. My project is a badminton image processing. It will mainly focus on badminton rackets and shuttlecocks. There are many images here in this dataset. I will go into it later. So here are our imports, the Gradio, CV2, random NumPy, and so on. The model and custom mapping. So YOLO will be our algorithm since it's the most used algorithm for image detection. It's currently one of the popular right now. So here is our uh, numbering or ID for shuttle, 38 for badminton rackets. Here is the location for our dataset. It's right here. We'll get into the dataset later. And history for the history of our logistic regression that we are going to use for our graph. So let's go move forward. Installment and box highlights. So box highlight, our result is the final output for our detection. Then here the draw box is for used for highlighting our objects such as the racket and the shuttlecock. The logistic regression graph. So here we start is our logistic regression graph. Here is our history that we talked about earlier. The CLF logistic regression and the graphs. There are two graphs. This one is mainly for the confidence score distribution, and the next one is the logistical regression accuracy. So our image file and formatting. So here is our random image. Since here in our dataset we are currently have 927 files or images that are in the dataset. So we chose a random image. We will choose a random image each time. That's why we have a button for a random image, and the formatting can be PNG, JPG, and JPEG. They can all be moved on because here in our dataset there's a lot of JPGs and JPEGs. So random choose, image all, and long road load random image. This is the button, and the user interface for Gradio. So with Gradio, this is the title of our radio user interface. Here are the buttons for that we will be using. This one is tabs, since this is for detecting the images and objects, and this one is for the accuracy graph, where the logistics and the other graph is gonna be shown. Uh, Also note that here, if you look here, not enough data yet. So if you later on we will see how it works. So basically, if you there's no data yet in the graph or in the Gradio user interface, it will show a. I'll show you here. It's just loading. While it's loading, let's just talk about the other piece. So this is the button for random images, and as you can see here, this is the detect again. So okay, it's loading. Okay, as you can see here, click on the accuracy graph. If we click generate analysis, there's not enough data yet. So it's because we haven't checked or randomized any pictures yet. So if we check here, so image, the thing with this accuracy or findings is that it's not really that accurate that much. It only highlights the objects that it saw or the one that's being highlighted. So as you can see here, it showed the racket instead of the shuttle, even though it's right there. But as you can see here again, a grid example for both objects. Let's see in the graph again. Slow graph, okay. Here, the shuttles, okay. Here, the racket is supposed to be here. So another one here. Oh, this is what I mentioned about earlier. Racket and shuttle here. And let's go for the analysis or data. As you can see here, we have a 6.2 accuracy to 2.5 accuracy for our logistic regression. And here is their confidential score. So it's as we go on, the images rise. So it's basically a streak on how many times we've seen how many consistent objects that we find for each randomize. So here, let's go again. For the dataset, it has many different pictures that are related to badminton. So that's why there's people, there's coaches, and actual games of badminton players. So yeah, yes, that is my final assessment for machine learning. It's a badminton image processing. It's a really good topic, but it needs more work to it, and that is all I could say for my assessment. Thank you.